third problem statement for this morning, which is bowling mechanism. Now, bowling is a fun recreational activity. However, our friends with cerebral palsy also have their own version of bowling that includes an assistive ramp and a switch that they can access to release the ball. I don't know what you guys saw. On this side, there were a lot of children playing with the balls, and the ramps are very cute. However, the picking up of the balls, the placement of the ball, and the positioning of the ball onto the ramp has to be done by a volunteer or an assistant. And as fun as bowling can be, how might we then use tech to enable players with cerebral palsy to experience the full game with independence? From picking up the ball to positioning it at best to seal the win, mastering the speed and aim of the ball, and maybe even exploring techniques such as the hook in bowling. These next 5 teams will be exploring different ways to address this issue, bringing independence and the full bowling experience to our friends from the Cerebral Palsy Alliance of Singapore. And first up to address this conversation, we have iTechies. Hey, come. iTechies, come. Yeah, iTechies, come. Come. You're on stage. Hello.
Good morning, everyone. My name is Shu Hua.
I'm Reynard. I'm Ziqun.
We are from IT College East in Mechanical Engineering, and today we'll be presenting to you iBowler. This is a picture of us with the finished prototype. The problem statement that we have is how are we able to enable users with limited mobility to experience a full and authentic game of bowling, which includes the ability for them to aim and bowl without any human intervention. iBowler is an interactive and assistive bowling ramp which allows people with limited mobility to have an authentic experience of bowling. The 4 requirements that CPAS has given us is firstly, accommodate to the standard bowling alley. Second, for it to be stable and able to withstand the loads. Third, the bowling ramp needs to be portable. And lastly, the bowling ramp needs to be equipped with automation mechanism. Our number 1 priority is to be able to position the bowling ramp and for it to be able to shift and adjust left and right.
Okay, so for our proposed solution, firstly, we have the portable bowling ramp. Secondly, the switch to release the bowling ball. And lastly, the switch to shift the ramp left and right. The next proposed solution is the iBowler design concept consists of the following components, which includes walking frame, detachable bowling ramp, rollers with guide rail, linear actuator, lastly, the servo motor. Next. Okay, so this is our prototype. So we have the walking frame, which is the main structure, the detachable bowling ramp, which is made by copper pipes, and the linear actuator to move left and right. And rollers with guide rail was implemented for the ease of movement.
So this is our electrical circuit. So this is a demonstration of us rolling the ball down. Can you replay that again? Never mind. So this is our linear actuator. It moves left and right. So our future plan is to able to lift the ramp up and down with our speed adjustment mechanism, and able to perform bowling hooking techniques with spinning automation mechanism too. So this is the end of our presentation. Thank you.
Thank you, team iTechies. Yeah, your video too solid lah. Just now I see the video on the side, slowly loading. That's very good. Yeah, so what can actually the people here expect when they come over to your booth? Can they play something? Can they try something? Can they get their hands on? What can they expect?
They can see our prototype lah.
Oh, see cannot touch, touch no see.
Can
See,
touch
pay
also.
money. Oh, okay.
Yeah.
See and touch must pay money? No need.
Don't need pay money.
Okay, just checking. Okay, so if they come over to your booth, they can play with the ramps lah, I'm assuming.
Yeah.
Okay, thank you very much, team iTechies. Thank you very much.
Thank you.
Okay, next on board, we have. So when I saw their prototype, I got quite scared. Because it looked like a weapon, but it feels very fun. So without further ado, I'm going to bring on board the next team on stage. We have Team Fast and Furious 10. Let's give them a big round of applause. Oh, can. Okay, let's go. You all brought an actual bowling ball. Okay, it's okay. This is mine first, no worries. Here you go.
Hi everyone, we're Fast and Furious 10 from Sengkang Secondary School. This is Caleb and this is Chloe. So, I'm Izul. Yeah, and we have one more group member, Chloe Ong, but she's down with COVID. So, yeah, Chloe, props to you if you're watching this. Okay, so first of all, our problem statement is the bowling mechanism. So this is to ensure that people with cerebral palsy can enjoy bowling as well from people who are not disabled. So for this part, I'll give to Caleb.
Oh, hello everybody. During our visit to the PSB Academy for the briefing, we discussed with the caretaker of children with cerebral palsy and were shown the inabilities of the children. Eventually, we decided we realized that yes, indeed, they cannot bowl, and so we decided to sketch our designs for the mechanism that would help to make ideas for the mechanism. We learned that there are 5 types of cerebral palsy, and our target group that we are handling with are mostly in the level 4 and 5, which means that they will have a caretaker to help them maneuver and carry things, as they are unable to move most of their body parts. So this is how we further conceptualized our ideas and yeah, the design specification and the design brief. Yes, our journey. Yes, it's next on Isu. So, what?
Okay. So this is our problem statement. So it's bowling mechanism. How might we make it possible for persons with cerebral palsy to fully experience the game of bowling as independently as possible? So in front of me is our product. It's called Easy Bowl, and this is how it works.
Okay, so basically, you're supposed to flip the switch so that the spring goes back, and it pushes the not really pushes the ball. It's so that the scream into the mic. Yeah, I am speaking to the mic. So when you flip the switch, the ball will be pushed by the solenoid mechanism, and flips it. And yeah, basically it pushes the ball, and
So also when you flip the switch, right, the this spring thing will push out the bowling ball, and we don't have a ram, but if there was a ram here, the bowling ball will be pushed downwards, and using the like gravity, the bowling ball can be pushed down the ramp into the like bowling alley. This product helps enable disabled people to feel included in the bowling. And it will also make people with cerebral palsy feel less left out when their friends can participate, like they can participate in bowling also lah. This product is measured to be the same height and dimensions as a standard bowling ramp, so it will fit on most bowling ramps. And that's the good thing about this product. It's actually very portable. So even when you're going out to go bowling, you can even bring this into your backpack, and you can bring it around with you. So it's very portable compared to standard other like bowling ramps lah. It's also battery operated, and the battery is rechargeable, so you can recharge it anytime when you want to use it.
The product is made of hardwood and aluminium, making it very durable so it can sustain falls from a high ramp. The product, yeah. So basically, Izu already explained that it was very portable. So as the demonstration, if you didn't get it, basically you flip the toggle switch, the battery converts power, supplies the power to the mechanism, pushing the ball down the ramp.
This is the images of the product on and off. So as you can see, when the product is off, the plunger retracts. So that's when the person is getting ready to play the bowling. When the product is on, the plunger pushes the ball down the ramp so that it will go into the bowling alley.
This is basically an overview of how it looks like, as you have seen multiple times. Never mind, you can skip this. This is basically like a small mock-up. It's not really how it's supposed to be.
So in conclusion, these are the product specifications. The product is running on a rechargeable battery, which is again quite portable, and you can recharge it anytime when you want to use it. So that's the good thing about it. And that's it. Thank you.
I was about to say something else, but never mind.
Hey, got any more? No more. Okay, thank you, Team Fast and Furious 10. Well done, well done. Yeah, just pass the mic back over that way. Great, thank you. Wow, look heavy leh, can Okay, very strong, very strong. All right, so that was the next team for bowling mechanism. Now, the following team, so I just want to share a bit more, right? I found out the next team is going to do a live demo on stage with the ramp and the bowling ball. So, for those of you who have taken photos, taken videos as well, this is my reminder to you, if you are on Instagram, Facebook, TikTok, do tag us at #engineeringgood or #tech4good, which is TECHFORGOOD, or #T4 G T2022. Again, #T4 G2022. Right, so that is my cue for you to fish out your phones and your whatever webcam or photo that you guys want to take, or take videos to post. And I'm going to get on the next team who will be showing a live demonstration of their product. Without further ado, wow, you shake until there. Can, I can feel your shake it from here. Right, next team we have Team MET. Let's give them a big round of applause.
Good morning, everyone. Again, my name is Shu Hua.
I am Hasif.
I am Brandon.
We are from IT College East, and we are here today with the Strike Master. The problem that level 3 and level 4 cerebral palsy patients is that they have difficulty aiming and throwing a bowling ball. Our solution to that is to create a device for them to be able to experience the game of bowling. And what it has is that it has a laser for assistive targeting. It is easy to use. And there is a switch right here in order for the ball to roll down. And now we'll go on to the project construction. Firstly, we generated and put our ideas on the paper, followed by a PVC pipe prototype. Then, once we are happy with the structure, we move on to 3D printing of the joints with that is PLA, followed by fabrication of the structure of the frame. So, and what we did is to just bend and cut copper pipes, and also the electrical components. Firstly, we used a 12-volt battery, which was really bulky, and now it is less bulky as we replaced it with just 8 AA batteries. And followed by assembly, and here we go, the Strike Master. Now I'll hand over to Hasif.
The features include the aiming device which uses laser, and there's a locker mechanism for it to close and open. It will be foldable and it will be open and in a closed position. We also have a linear actuator which can release the ball. And the structure of the Strike Master is using copper material, which make it durable. The benefits include that you will improve their aiming and a higher chance to knock down the pins. Once they knock down the pins, it will increase their self-confidence. And they will engage and enjoy the activity. It is also transportable, so it can be stored in anywhere. And space saving. Our future plans are to install caster to improve the movement. Secondly, is to 3D print the joint using carbon fiber material. I will pass the demo to Brandon.
And for now, I'll show you a short video of the demonstration. And now I'll show you a live demonstration. So basically, you just on the actuator. Where is it? Oh my god. Yeah, and that's it. Thank you.
Alamak. Thank you, Team MET. Well done. Wow, a lot of suspense before the ball drop. No, purposely one, right? Purposely one, right? Okay, well done, well done. Thank you very much. All right, bringing on the next team. Oh, wow, very big, very big. The next team will also have a very physical prototype. I saw some of you guys taking photos and videos. This next one will also be a very good opportunity for you to take videos and photos as well. Can I get the next team? So I need to share this also. This team is from SIT, Singapore Institute of Technology. So can I get the next team onwards? Team Hope. Can you give a round of applause, please? Wow, the one with the one hand very strong, not bad. Wow, one hand, look at the biceps.
off downstairs or something?
Okay. Alright, guys. Ready? Alright. Good morning to every one of you beautiful people out there. My name is Mervin from Team Hope, and these are my group members. Together, next. Together, next. Together, we come from the computer engineering course from the Singapore Institute of Technology, hoping to bring our IT and engineering expertise to bring you rampability, our take on making every launch into the bowling lane a unique experience for individuals with cerebral palsy. Next. All right, so some of us may have had the chance to understand that the current conventional ramp has the absence of skill and autonomy factors, making bowling not just challenging, but also unappealing for these individuals. However, rampability helps with that. Next. Through the use of the features we've implemented onto the ramp, users will be able to take control on how they would like to launch their bowling ball. More on this later, as we'll be doing a demonstration for each of these features. Next. Fun fact, our ramp was built from scratch. So we designed rampability such that there will be opportunities for us to improvise on it further in the future, and more on that later as well. This also allowed us to design our ramp such that it's able to pivot horizontally, vertically, and even angularly. Right, next. Okay, so firstly, we have buttons. So each function of our ramp can be controlled by a button, so for the ease and convenience of our users. So the buttons, while you are not able to see it here, they are placed on the user's point of view for their convenience. Next. Next up, we have a height adjustment system. So this, as you can see, our demonstrator, Puran, he is using a button to raise the level of our ramp. And he can also lower the level of the ramp as well using another button. So one thing to notice is that for the slide that's attached to the ramp, as the ramp goes up, the slide will also go up. So in a way, we can control the speed of the launch into the bowling, of the launch of the bowling ball into the lane. Of course, you know, taller height means more potential energy, and this converts to higher kinetic energy and higher speeds into the bowling lane. So the height adjustment function doesn't just function as a form of comfort where users can adjust the height to their preferred levels, but also as a way for them to control their speed that they want to launch into the lane. Next up, we have a dual pivoting function. So users can actually steer the ramp to around 40 degrees left or right, and at the same time, they can also shift the ramp left or right as well. Next. Okay. So after the user has decided on where they would like to launch the bowling ball, then with a touch of a button, we have a spring-loaded function that allows us to that allows the bowling ball to be pushed from the slide down to the bowling lane. Right. So we hope that this added flexibility will enable users to feel more unrestrained and engaged in the game of bowling. So now that we have shown a short demonstration of how rampability works, it is time for us to appeal to all of you. If what you have seen so far was not reason enough for you to vote for us, we actually have made plans to further develop our project through our school module project this trimester. So we intend to add certain additional features that will enhance the user experience, such as safety features and other assistive features. Next. If possible, we also desire to expand our reach not just to persons with cerebral palsy, but to also other individuals whose circumstances have rendered bowling difficult for them to play as well. Right, next. Not yet, the previous one. Right. Your invaluable support would mean a lot to us in our journey to inspire these individuals to enjoy a sense of joy and independence in bowling again. So if you have any questions, you can feel free to drop by our booth later, and we can you can play with it. You can see how it works, and you can ask us questions as well. So we earnestly ask for everyone to be a part of our quest to make our society a more inclusive society for one and all. Thank you.
Thank you, Team Ho. Huyo, macam Shark Tank pitch, ah. You want looking for investors, ah? But actually, I'm very curious. It looks very. It's okay if I talk to you. You like I anyhow come to you.
Sure.
It looks like a very intricate item. How much did it take cost-wise to create this for yourselves?
We used up the budget for our from the one that's provided by Tech for Good. We also funded a little bit more for some of our linear actuators, our stepper motors,
Right.
and we also used our Arduino kits that were given to us by the school to power up some of the Arduino boards that power up some of the functions that you're seeing.
Right. And how much does that cost in total? Agak-agak, like plus minus lah.
Probably 400 to 500, maybe more.
400, 500. Okay, got you. Thank you very much. No, for all those investors out there, think of the cost, $400 to $500. Okay, just letting you know. I actually saved you time from helping them carry lah, so you're welcome.
All right, thank you.
Thank you so much. Right, Team Hope. Okay, and now we're on to the final team for this whole morning. We have a team from Raffles Girls' School Secondary, and their team, they're actually very smart lah. Their team name actually they promote us also. Their team name is called Tech for Good. So let's bring them on board. A round of applause for the last team this morning, Team Tech for Good.
Hello everyone, we are Team Tech for Good, a group of 14 to 15-year-olds from Raffles Girls' School Secondary.
I am Trinity.
I am Alyssa.
I'm Chelsea. And I am Kaijie.
Today, we will be presenting on a prototype addressing the problem statement. How can we enable those with cerebral palsy play bowling as independently as possible? Firstly, we joined Tech for Good not only to understand more about assistive technology, but also to attempt to put on our thinking caps and make changes in our communities. Additionally, we were humbled to receive advice from our contributors, our main mentor Ash and community partner Hari. Ash is a mentor assisting us in our Tech for Good journey, giving us timely advice when necessary, while Hari generously shared about his experience as someone with cerebral palsy, giving us critical insight about how to begin designing our solution. We would also like to honor our very own in-school design and technology teachers, Mrs. Leong and Mr. Asman, who assisted us and contributed a lot in our prototyping process.
Curious to find out more about our design thinking process? Well, though our specific prototyping journey is up on our Instagram at Tech for Good, that's TACK for Good, we will summarize our key highlights in our Tech for Good journey today. In June, we went for the Tech for Good bootcamp and met our mentor and community partner. Next, it was followed by months of tiring yet rewarding virtual meetings. During our prototyping process, we headed to the Science Center's makerspace to create our low-fidelity prototype. And recently, we spent 5 consecutive days of hard work in our school's design and technology studio making our final prototype.
Okay, now you must be thinking, what exactly is our chosen problem about? Our problem statement is, how can we enable those with cerebral palsy to play bowling as independently as possible? We chose to tackle this problem as we realized that though assistive bowling ramps were invented to assist those with cerebral palsy to play bowling, the concept of an independent bowling experience was not present, as volunteers needed to be present at all times to move the ramp in order to aim for the bowling pins on the ground. Our end users include persons of all ages with cerebral palsy, at a disability level of 3 to 4 according to the Gross Motor Function Classification System, meaning that they are able to use assistive mobility devices with or without physical assistance.
Presenting our project, the Cerebral. Our solution consists of a modification of the current assistive ramp. The ramp is attached to a motorized turntable that the user can rotate in order to aim the ball and then release it. The mechanism is entirely controlled by buttons, which are portable and can be attached to their wheelchairs for accessibility. This allows people with cerebral palsy to bowl independently, as volunteers no longer need to help the user rotate the ramp to aim. Our system is made up of an Arduino, several cables, push buttons,
batteries, plastic tubes, a turntable, and motors.
Well, now you might be wondering, how exactly does our prototype work? Firstly, the volunteer puts the ball on the ramp. Next, the volunteer can assist to place the buttons at a convenient location for the user. Thirdly, the user aims the ball by pressing the green button or the yellow button, and then the red button to release the ball. Putting it together is also simple and user-friendly. The unique selling point of our product, other than the turntable, is how the user can actually move to any comfortable location beside the ramp or behind the ramp and get ready to bowl. If you're interested in trying out the Cerebral, head to our booth over there later to try to get on our leaderboard for knocking down the most bowling pins. Winners will also get prizes if they manage to get a strike.
If you happen to fancy our project, scan the QR code located at our team poster on our booth. Hope you enjoyed the Cerebral and have a great day ahead. Thank you so much for listening to our sharing.
Wow! Fuyo! Wow, teamwork. Well done, Team Tech for Good. So it's Tech because your names are TACK, is it?
Yeah.
Oh, you are 2 letters away from Attack for Good.
Yeah, so this is Trinity, Alyssa, Kai Jie, and Chelsea.
Wow.
Yeah, so
well
it's
done, well done.
TACK.
Super, super cool. Okay, I just want to have a question with you. I think many of us want to find out, right, about what was perhaps the biggest challenge you faced throughout the past. Wow, you answered already, I know, right? Okay, what's the biggest challenge you faced over the past few months in Tech for Good, in your Tech for Good journey?
I think one of the biggest challenges is actually understanding the people with cerebral palsy, because as you might realize that there's not a lot of awareness in our community for those with cerebral palsy, and which is why we ourselves as a team didn't really know much about them until we were invited down to the Cerebral Palsy Alliance to play bowling with our national poker player Aloysius Gunn. So that was really an enlightening experience, and we got to see how people with cerebral palsy live their daily lives and go to school and go to work. And this is how we started to design a prototype according to their needs. So I think that very first hurdle was the biggest problem we faced when designing our prototype.
Well done. Thank you. I think that deserves a big round of applause, the response. Thank you very much. Yeah, and I think really thank the team and all those who are here today for doing your part in opening up to these conversations that, like you said, is a lesser known community in Singapore. So thank you very much. Thank you so much. All right.